Hey everyone! Today I'm going to talk about the term edge computing and why it's one of the fastest growing technologies today. I'll start with some historical context and then share the key benefits of edge computing for connected devices, also known as the Internet of Things. Computing started as a highly centralized technology. Early mainframes like the IBM 700, created way back in 1952, weighed as much as 16 tons and included over 1,700 vacuum tubes. These were designed for batch-oriented business and scientific computation. When mainframes were the dominant type of computer, computation was centralized. After the invention of the microprocessor by fellow Texan Jack Kilby of Texas Instruments in 1958, the door was opened to decentralized or desktop computing. Now, over the years, computing has bounced back and forth from the desktop to mainframes and back again. Decentralization has boomed over the past decade with the explosion of smartphones, which are essentially powerful handheld computers. Cloud computing represents a swing back towards centralized computing and has flourished due to improved internet connectivity speeds. According to the research firm Gartner, around 10% of enterprise-generated data is now created and processed outside of the traditional centralized data center or cloud. By 2022, Gartner predicts this figure will reach 75%. The shift to edge computing may have a profound impact on an organization's systems and how new digital products are built. Today, an IoT solution has to cover a much broader scope of requirements. We see that in most cases, organizations opt for a combination of cloud and edge computing for complex IoT solutions. Cloud computing typically comes into play when organizations require storage and computing power to execute certain applications and processes and to visualize telemetry data from anywhere. Edge computing, on the other hand, is the right choice in cases with low latency, local autonomous actions, reduced back-end traffic, and when confidential data is involved. There is an explosion in the amount of data being generated by digital devices. The traditional model of processing and storing all data in the cloud is becoming too costly and often too slow to meet the requirements of the end user. This is motivating a move towards an edge computing approach that facilitates the processing of device data closer to the source. We're seeing smaller and smaller sensors with high-powered microchips that are enabling this move to the edge. Some of these companies are clients of Softeq, like Intel, NVIDIA, and Marvell. There are several key benefits of edge computing. A key goal is to overcome network latency and improve speed. If the IoT application requires a sub-second response time, then waiting for a request from the cloud may simply be an issue. For instance, a safety-critical control system operating an industrial machine might need to stop immediately if a human is too close. Similarly, autonomous vehicles or augmented reality applications need a response time below 20 milliseconds. Moving the processing of the sensor data to an edge gateway avoids network latency and achieves the desired response time. Cost is also a driving factor for edge computing. The bulk of telemetry data generated by sensors and actuators is likely not very relevant for the IoT application. The fact a temperature sensor reports an 80-degree reading every single second might not be interesting until the sensor reports a 120-degree reading. Edge computing allows for the data to be filtered and processed before it is sent to the cloud. This reduces the cost of data transmission, storage, and processing. Deploying artificial intelligence analytics algorithms or machine learning models to an edge gateway allows for the computational processing to be performed on smaller data sets. Edge computing will often be more computationally efficient to process this type of data. Another feature is that many digital products need to be autonomous in their operation. This allows them to achieve the required safety, reliability, and user experience. Edge computing provides the ability to have local storage and local computation. The device can then continue to function even if it is not connected to the network. Finally, edge computing can improve the security and privacy of an IoT application. Edge computing can reduce the number of sensors and actuators connected to the internet. This reduces the potential attack vector of security attacks. Local data processing and filtering by an edge gateway can also reduce the amount of sensitive and private information that is sent through a network, addressing privacy needs or regulations for the application. So in conclusion, it's important to consider edge computing as complementary to cloud computing. To help our healthcare and wellness customers better understand edge computing and how it relates to cloud computing, we're authoring a white paper in conjunction with the research firm Parks & Associates. Keep an eye on softeq.com/blog for this upcoming report and many more helpful articles. Thanks for listening.